Good morning. This is your stats sensei, Mr. Spensey, and we're going to be looking at a 2009 question 2 problem that deals with the normal, the distribution of means, and the binomial all wrapped up into one question. So a tire manufacturer designed a new tread pattern for its all-weather tires. Repeated tests were conducted on cars of approximately the same weight traveling at 60 miles per hour. The test showed that the new tread pattern enabled the cars to stop completely in an average distance of 125. So they're telling us, hey, your mean is about 125 with a standard deviation of 6.5. And the stopping distance are approximately normally distributed. Generally speaking, they tell us they say something about normal, we're working with the normal. And we are here. So basically we know we have a normal. We have a mean of 125, a mean of 125. We have a standard deviation of 6.5. They say, what is the 70th percentile of the distribution of stopping distances? Okay, so we have a normal. They want the mean. We have the mean of 125. This area needs to be 0.70, and we're looking for this X value. That's what we're looking for. Problem is, we don't have everything we need. So we want the probability that that we have our stopping distance is, we're looking for that X. So let X equal the 70th percentile stopping distance. And whenever I get a problem like this, I write down, well, it's a normal, so I'm gonna write down Z equals X minus mu over sigma, and I start plugging in what I have. Well, what I have is this. I know I'm looking for this. I know I have 125. But I also know I have a standard deviation of 6.5. But what I'm missing is a Z-score. And I go, oh, wait a second, I have an area. So all Z's are centered at 0. And I shouldn't have shaded that. So all Z's are centered at 0. And I'm looking for this Z-score. So I can do that by doing an inverse norm. So second bars, because it's a percentile. And inverse norms are 0.7, because it's going to be from negative infinity all the way to here, mean of 0, standard deviation of 1. And I end up getting a 0.5244 as my Z-score. And at this point, I could solve by algebra. So I'm going to multiply times 6.5. And then add 125. And I end up getting about a 128.408. So X equals 128.4086 feet. All right. Once again, how did I get that value? I went second vars, inverse norm, area, because it's a percentile rank, negative infinity to that X is 0.7 or 70%. Z-scores all have a mean of 0 and a standard deviation of 1 and 0.5244. Okay, so that's the first part. What's the probability that at least 2 cars out of 5 randomly selected cars in the study will stop in a distance greater than what was shown? Wow, so that's kind of a problem. So first off, there's a probability at least 2 cars out of 5. So here we have a specific number of trials. Every time they give you a specific number of trials, I go, well, if my probability is fixed, then it's a binomial. So I have a specific number of trials, so this tells me it's a binomial. This tells me my trials in this case. equals 5. And what I'm looking for is the probability that we're going to stop in a distance greater than what was above. And I have 0, 1, 2, 3, 4, 5 cars because we binomials always start at 0, at least 2 cars. So that means I'm looking for this group right here. So I need to identify my p-value. Well, let's look back up our drawing up here. 70% of the cars stop in a distance less than that. So that means 30% stop in a distance more than that. So my p-value is going to be 0.30. All right. So in this case, we want to know the probability that x is greater than 2, greater than or equal to, where x is the number of cars that stop in a distance greater than 128 feet. All right, because that's what we had before. All right, so binomial. Well, to show my work is going to be 5, choose 2. Our probability is 0.3 squared times 1 minus that is 0.7. 5 minus 2 is 3 plus ... plus 5, choose 5, 0.3 to the 5th times 0.7 to the 0. Now, we always subtract out what we don't want. So on the calculator, we're going to go 1 minus binomial. We know it's a CDF. The reason it's a CDF is we had more than one value circled. Trials equals 5, probability 0.30. X, the highest value we didn't want is 1. So 1 minus second vars, binomial, CDF, trials is 5, P is 0.3, X value in this case happened to be 2, excuse me, 1. I keep using 2 today, that's a bad deal. And I get 0.4717. So in a group of 5 cars, there's a 47% chance that 2 or more stop in a distance greater than 128.4 feet. What's the probability that a randomly selected sample of 5 cars in the study will have a mean, this is important, mean stopping distance of at least 130 feet? Well, we're talking about a group of 5. They've told us previously that we're normal. So we're now working with a normal still. And in our case, the mean is still 125 because the mean is the mean. But we have a group of 5, so our standard deviation is now the standard deviation of x bar, which is the standard deviation divided by the square root of n, which in this case was our original standard deviation was 6.5 divided by the square root of 5. Now you're going, wait a second, this sample size is too small. And it would be, but the underlying population is normal. Since the underlying population is normal, we're good to go. If it were anything but normal, we couldn't do this problem. Then we also know that our sample size, or our X bar, is 130 and N is 5. So what this looks like, and we want to know the probability that X bar is greater than or equal to 130, where X bar is the average stopping distance of 5 cars. All right, so we're looking for the average stopping distance of 5 cars. Our drawing is going to look something like this. We still have a mean of 125, but we want to know 130 and greater. All right, and our standard deviation for this is going to be 6.5 divided by the square root of 5. So Z equals X bar minus mu, standard deviation divided by square root of N. So we want the probability that Z is greater than 130 minus 125 over 6.5 divided by the square root of 5. And at this point, I'm going to go to my stats test Z test. So stats test Z test means our mean stopping distance in this case was 125. Our standard deviation was 6.5. Our X bar in this case is 130, and our sample size happened to be 5, and we wanted it to be greater than. And we end up getting the probability that Z is greater than 1.72 1.7200 equals 0.0427. All right, so the answer to the question, there's less than a 5% chance that 5 cars would have a stopping distance of greater than 130 feet. All right, so this would be your work shown. I hope that's helped, and look forward to seeing you on the next one.